Hey Tara, how are you?
Hey, Majid. I'm good.
Okay, good, thank you. So let's start a quick conversation about OpenClaw. So
Hmm.
today we want to go a bit more deep dive into how OpenClaw works, especially the memory.
Yeah, let's do it.
And then if you have any questions, please stop. It's just more of a conversation,
Hmm.
and we'll just share what we learned so far. Okay, so um, let me share my screen and take it from there. Okay. Okay, do you see my screen?
Yeah.
All right. So we start with OpenClaw and GitHub page, which is amazing. It has like 225,000 stars as of today, which is February 24, 2026. And it has been very popular and it has been growing in popularity tremendously, as you can see from this image. And what OpenClaw is a personal assistant, basically. So you connect it to your own personal calendar, email, and things like that. And through some channels like a Slack or Google Chat or Microsoft Chat or from a chatbot, you deal with it as a chatbot. Your user interacts with it as a chatbot and asks it to do things, which is what agents are supposed to do. Is like personal assistant agents are supposed to do, and it works on different operating systems and platforms, and it makes it very practical for a lot of people to use. Do you have any question, comment
No,
so
let's.
far? Yeah. So now we want to look at a bit of architecture of OpenClaw and the two aspects that I think are the most interesting. I would say the first interesting like innovation in how OpenClaw works. By the way, this is a fully open source, which makes it uh, more interesting for people that can just copy and use it. I think the first uh, emphasize emphasis of the OpenClaw architecture is that local first gateway. And I see if what they mean by local gateway can just um, explore this a bit more. Oh, the link doesn't work. Okay, I was expecting it to this to work. Anyway, so the highlights is that it's designed for day-to-day use, so it connects to WhatsApp. You can run it on a tool on a server wherever you have on your own, and then it allows you multi-agent routing, so routes inbound channels and counts. And oh, what happened?
It's not working.
It's not our internet, is it?
No.
We're good. Okay. The other interesting aspect of this is the memory. Um, the memory aspect is interesting, and that's what we're going to explore a bit more here. So every communication goes through a gateway, and then it goes to different agents and web chat UI and so on. Now I found this article that's very interesting. Is on Medium. I will post a link for you to study. It's a very short article, but it's very informative how it works. So, and I read through some part of it, and we make some comments for learning. Says the OpenClaw implements a radical departure from conventional AI memory systems. So, plain markdown files as the source of truth, layered with hybrid semantic search. This is interesting because um, for memory, everyone was thinking about the scale having more sophisticated rags and graphs and more heavier backend systems to support the memory, but they just save it in plain files. and markdown files, and that is.
Mm-hmm.
And I have some opinions on why this works, why this is a good, interesting approach.
Yeah, the question is where do those files go, right?
Yeah, so they will be kept in local.
Mm-hmm.
So this is how it works. And this is a very interesting graph. So user interacts through chat interfaces. Everything goes through a OpenClaw gateway, which is a persistent background process, such as like something like Fast API, but no, it's written in um, uh, TypeScript. So it's a
Mm-hmm.
TypeScript server listening to messages. And then
Mm-hmm.
it can make agentic calls to Claude and GPT for interpretation, reasoning, what should I do, or even pulling up skills.
Mm-hmm.
This happens at this point. And then if it is supposed to do some actions like reading emails, sending emails, or booking calendar events, it would do it from the gateway. But what's more interesting is the memory system, and it's called the brain. But it's so simple. So you have basically three main categories. You have the daily logs that is created by the Claude or agentic summarization every day, automatically
Mm-hmm.
generated and stored locally. And then you have a memory MD. This is long term, curated facts and more persistent, not easier to change. And then you have session summaries. So sessions are individual interactions that could last for minutes to hours, and that's how it is. And then you have a supposedly private section that is off limit. It's not supposed to be accessed or changed,
Mm-hmm.
which is probably the identity of the agent or some sensitive information like authentication
Authentications.
through email, calendar access points,
Mm-hmm.
API keys, and so on.
And where are they? All of those memories, all three. Do you know? Like,
Yeah, so I think the way it works is that they sync they sync these. Oh, the private, I don't know. I don't know how to protect the private. Probably some kind of encoding and
mm-hmm.
local. But these files, I assume they're synced to a SQLite database,
Mm-hmm.
and the way they pull when they eventually need to do some RAG, basically they need to pull out some memory. It's a weighted average of 70% vector
Wow.
search and 30% keyword search, BM25.
Mm-hmm.
And then the article basically explains why this is such a good idea to have 70% weight and 20 and 30% BM25. Um,
Mm-hmm.
because of course vector search is like based on this is that cosine similarity, and you have embeddings that are stored on SQLite and SQLite Vec, and then it pulls up semantic similarities from the memory, okay,
Mm-hmm.
and matches whatever is happening live on the gateway. And then
And there's no cloud API for those vector,
no,
right? Everything.
it's all no. I would tell how they do the
Mm-hmm.
vectorization, and then the keyword search is whatever. If you want a specific error code or specific names you're looking for, that's where the keyword search comes into use. And they use a union basically to say for all the searches, the final score is always weighted average of these two factors,
Mm-hmm.
and then the ranking and scoring. And this is the most important probably part of the memory is how accurate things are being pulled up.
Mm-hmm.
It's pretty simple, but they claim this to be the best working solution. So there's not much research. I haven't seen like a optimization to get to 70/30. It seems to be just a practical choice they made along the way of making so many different other choices. Just okay, let's put the 70/30 and see how it works, and it worked. Okay.
Any benchmark they've done?
No, I don't think
No.
so. It's just OpenClaw's own formula. They came up with it. There
Mm-hmm.
is another formula they mentioned. There was RRF. The RRF is basically works treats them as equal weights, and then I think it's used a geometric mean to create a new score and ranking. Okay.
Mm-hmm.
And then the last thing is how the embedding is done. Basically, if you go from if you have a local embedding model, install the transformers install, it will probably use that. If not, they would try to uh, hit the OpenAI API for embedding. If not, Gemini. If not, then it would only do the keyword search and then just forget about semantic search altogether and embedding.
So the API here leaves the device for to get
Yeah, I think
OpenAI.
it's user's choice. If you give it the API keys for different models, it would use it. Otherwise,
Mm-hmm.
fall back. It can still work without semantic search, basically.
Mm-hmm.
Yeah. So that was the.
Do you know if you want, as a user, you want to stop OpenClaw from devices? Like, can you just simply stop it?
Yeah. So
Well,
yeah, that's a persistent background process. You can stop the process and the whole thing. It's like a server, backend server. The whole thing would go down.
mhm.
But then some of the issues with this architecture is that even though it's good to have MD files so people can read it, um, it would be some issues with it. Obviously, someone can come in and change a few words within your memory, or change some important information on the daily logs. This being a persistent, like personal, personal assistant, so it probably has a lot of personal information in it. Right?
Mm-hmm. Yeah.
And then you're recording all of that into just files that anybody can read. So probably having another layer of like encryption here would be good. And also the issue of latency goes because like SQLite is very limited in terms of scaling up the size. Let's say if you
Mm-hmm.
keep working 1 day, 2 day, 3 days, it would be okay. But I don't know. It's like you have thousands of sessions, hundreds
Right.
of days. How is this gonna scale? The scale is issue, right?
Right. Right.
Um,
Yeah, that was my next question. How much you can remember for how far, in the
yeah, and also you have gateways towards outward. Like you are heavily dependent on calling Claude GPT here for LLM use, and
Mhm.
also for embeddings. So you have to. This system has to be connected to internet. That's what I'm saying. So
Mhm.
the claim that it is on-prem isolated,
Edge on
it's
edge.
not completely true. Like yeah, your files are on your local, but the system itself is always connected to
Hmm.
outside LLM and memory, outside LLMs and APIs. So it's doing a lot of outside calls back and forth. Okay, so
Will you use it personally on your own very own personal device?
yeah, you can install it on any device, and you can have an app. You can install the app on your phone and just use it through your app as
Hmm.
well. Yeah, so that's in a nutshell the memory system for OpenClaw. There are things I like. It's so simple. So you divide the memory into sessions, daily logs, and full memory. So it gives you three layers of abstraction over time.
Hmm.
So sessions basically have all the back and forth conversations. Memory is long term. It's like for important facts. The process of curating session data to go into memory is not clear to me. What, for example, makes a fact to be placed into the long-term memory?
Hmm.
How is it curated? That's an issue. That still remains an open issue because, and then another problem is that how do you fix the precedence issue? Like I say, today you want to go to, I don't know, to you want to book a flight, let's say, to Miami, and then you say I want to book a flight to Miami, so it goes to memory. The next day you say I want to book another flight, so it assumes that you are going to the same location. But if you have, and if you change your mind and you change location, then the relevance of the memory to the ask has to be examined. Yeah, so there are still issues, but that's an interesting approach, I would say, so far.
Mm-hmm. Cool.
Yeah, thank you very much.
Okay.
As
Thank
we are
you.
studying is still more. And one thing is still missing is that we don't know how they score to against benchmark memory benchmarks. So we have like Locomo and long mem sets of thousands of dialogues with questions. It would be interesting to see how OpenClaw scores on the benchmarks as well.
Mm-hmm.
Yeah.
Cool.
Okay. Yeah. Thank you for your attention. I hope learn something about OpenClaw and the memory, and I'll talk to you next.